Welcome our students. Today we will start with the first lesson in the geometry of the third year prep. The first lesson is talking about the basic definitions and concepts on the circle. We will start this lesson by studying some definitions, then we have some examples on these definitions and colors. The first definition here is called the circle. What's the meaning of the circle? It is a set of points of the plane which are at a constant distance from a fixed point in the same plane. For example, we have in this circle the fixed point is called M, which is the center of the circle. We have some points lie inside the circle, like the point A and the point B here inside the circle. We have also the points C and D. We have the points C and D lie on the circle here. Also we have the points E and F lie outside the circle here and here. The second definition we have in this lesson is the radius. The radius, it is a line segment with one end point at the center of the circle and the other end point on the circle. Like here, we have the center of the circle is M, and we have 3 points A, B, C. All of them lie on the circle. Any line segment joining between the center of the circle and any point on the circle is called radius, like AM or BM is called radius, and MC is called also radius. We must know that AM equal BM equal CM. All the radii in the same circle are equal in length. All of them equal R. The second definition we have is a chord. We have the third definition, the chord. It is talking about, it is a line segment whose endpoints are any 2 points on the circle, like AB. A is a point, B is a point on the circles. If we join them like this, that's called a chord. We have also CD is another chord. We have EF is the third chord. All of them are chords not passing through the center of the circle. That's the important notes, that the chord doesn't pass through the center of the circle. The fourth definition here is called the diameter. The diameter, it is a chord passing through the center of the circle. That's the difference between any chord and the diameter. The diameter is a line segment passing through the center of the circle and joining between 2 points lie in the circle. Like here, the diameter AB. The point A and B lie in the circle. They are passing through the center like here. we must note that the diameter AB, or any diameter, it is the longest chord in the circle. Any another chord is short with respect to the chord AB, like here. We have some rules, like the circumference and area of the circle. The circumference of the circle equal to pi r, or pi d. We have studied before in the previous years that the diameter equal 2 multiply the radius length. So we can replace the diameter by 2r. The area of the circle equal pi r square. And we note that the pi is a constant value equal 3.14 or 22/7. The first corollary in this lesson, it is talking about the straight line that passing through the center of the circle and the midpoint of any chord. The result that it will be perpendicular to this chord. Like here, we have a straight line drawn like this, passing through the center of the circle, which is M, and bisect the chord A, B. It passes through its midpoint. The result that it makes a right angle with this midpoint. Before going to the second and the third corollary, before going to the second and third corollary, we must notice that this line, the straight line, it makes three things. The first, pass through the center of circle. The second, pass through midpoint of circle. The third point, it will be perpendicular sorry, it is not passing through the midpoint of the circle, it passing through the midpoint of the chord. The third point, it will be perpendicular to the chord. I want to note that in the first corollary, it started with that the straight line passes through the center of the circle. So the first point is given, and it is passing through the midpoint of any chord. So the second point is given. So the result will be it is perpendicular to the chord, and it comes as a complete or choose in many exams. I will leave these points here and go to the third page and show the second and third corollary and come back to these points to show that which points are given and which points are missing. We have here in the corollary 2 that the straight line passing through the center of the circle. So that's the first note in the above page, and it is perpendicular to any chord. So the result here, it will bisect this chord or pass through the midpoint of it. If we go to the previous page, we will find that the second corollary was given that the straight line passes through the center of the circle and perpendicular to this chord, and the missing point, which come as a complete or choose, that the straight line passing through the midpoint of the chord or bisects it. So any corollary, it was given 2 points, and the third point is missing. We must know what is given and what is wanted to be completed or chosen. We will go to the next page and see the corollary number 3. Here we have that in the third corollary, the perpendicular bisector to any chord of a circle. Let's see what's the result. It will pass through the center of the circle. So the given here, the first point, it is perpendicular and bisector. So the result was the center of the circle. If we go to the previous page, we will see that the third corollary have given us that the straight line is a perpendicular and bisector to the chord, passes through its midpoint. So they wanted that we say that this line passes through the center of the circle. We have in the first example here AB and BC are two chords in the circle M, as shown in the circle. MD is perpendicular to AB and intersects AB at the point D. MD is perpendicular to the chord AB, and D is the intersecting point. Also, MD intersects. We have that MD intersects the circle at the point E. Also, we have that X is the midpoint of BC. Here, X is a midpoint of BC. Measure angle ABC as a given in the figure equal 56. Here, the first required to find the measure of angle DMX. That we will start our proof that we have in the shape BXMD is a quadrilateral. We have measure angle B equal 56. We have that measure angle MDB equals 90. We must know the measure of angle X to find the last angle, which is the measure of angle M or DMX. So since x is midpoint of BC and mx comes out from center of circle, therefore measure angle BXM equals 90 degree, as the first corollary that the line comes from the center of the circle as mx and passes through the midpoint of this chord, which is BC, so it will be perpendicular to the chord at x. So we have that measure angle B equal 56, measure angle MDB equals 90, measure angle MXB equals 90. The last angle wanted, which is the measure of angle DMX. Since the figure DMX is quadrilateral, therefore all the measures of its interior angles we have that the figure DMXB is quadrilateral. We know that is quadrilateral, and all the points, all the angles of the quadrilateral, the sum of these angles equals 360. Therefore all measures of interior angles of quadrilateral their sum equals 360 degree. Therefore measure angles DMX equals 360 minus 90 plus 90 plus 56 equals 124 degree. If we go above to see the second required is to find the length of DE. We will erase all the written on the figure, but we will write again the measure here as 56. We want to find the length of DE. We notice that we have that the length of AB equal 8 centimeter, and since D is a MD is perpendicular to AB like here, so D must be the midpoint of AB. So the length of AD equals 4 centimeter, and BD also equals 4 centimeter. If we make a construction here like this, joining MA, so MA will be a radius equals 5 centimeter. So it will be easy to find the length of MD by using the rules of Pythagoras. MD square equals MA square minus AD square. So we will get that the length of MD by the squaring root of MD equals 3 centimeter. And we note that the radius length equals 5 centimeter. So by subtracting all the length of ME, which is equal to 5 centimeter, minus 3, so we will get that the length of DE equals 2 centimeter. This proof will be written below as shown here. Construction. Draw MA as a radius equals 5 centimeter. So in triangle DMA, MD square equals MA square minus AD square equals 25 minus 16 equal 9 centimeter square. Therefore MD equals square root 9 equals 3 centimeter. Since ME equals 5 centimeter minus 3 centimeter, we have that the length of DE will be equals 5 centimeter minus 3 centimeter equals 2 centimeter, and the 5 comes due to the length of the radius equals 5 centimeter, and 3 comes due to the length of MD equals 3 centimeter. So the remainder will be DE equal 2 centimeter, and this was the second required in this problem. We will show that the second example here. In the second example, we have that AB and AC are two chords in circle M that includes an angle of measure 120 degree. We have that the measure of angle AE equals 120 degree. D and E are the two midpoints of the two chords AB, as we see here, and AC respectively. DM and EM are drawn to intersect the circle at X and Y respectively. We have that DM intersects the circle at X and EM intersects the circle at Y. The required here to prove that the triangle XYM is an equilateral triangle. We want to prove that the triangle XYM is an equilateral triangle. We know that to prove that all the angles of the equilateral triangle, we must know that they are equals 60. So we want to prove that all the angles, all measures are equal 60 degree. How to prove that? We will see in here. We will start our proof that since MDAE is quadrilateral and MD perpendicular bisects AB, ME bisects AC. Therefore, measure angle MDA equals measure angle MEA equals 90 degree, because any line comes from the center of the circle and bisects a chord as AB, so it will perpendicular to it. Also we have here ME bisects the chord AC, so it will be perpendicular to it. As the previous example, we want to find the measure of DME. Therefore, measure angle DME equals 360 minus 90 plus 90 plus 120 equals 60 degree. So we find that the measure here equals 60 degree. Since measure angle DME will be equal measure angle XMY equal 60 degree, because it will be vertically opposite angle with it. As here we get that the measure of angle equals 60 degree. Since we have that mx equals my equal of all the radius of the circle. We know that any radius in this, all the radii in the circles are equal in length. So mx equals my equal of. So we have the triangle mxy now is an isosceles triangle, and the measure angle xym equals 60, which is the vertex angle here. The measure of angle equals 60 and it is a vertex angle. So by a simple calculation we will get that measure angle mxy equal measure angle myx equals 180 minus 60 over 2, or divides 2, equals 60 degree. Therefore all measures of angles of triangle mxy equals 60 degree. So triangle mxy is an equilateral triangle. So I will revise the answer with you. We have here that measure angle DAE equal 120, because D and E are the midpoints of AB and AC. So we proved that measure angle E and measure angle D equals 90, and since the quadrilateral AEMD, its total of measures equals 360, by calculation we get that the measure of angle M here is 60, and because there are two vertically opposite angles here, so this angle will be 60. Since MY and MX are two radii in the circles, so this triangle is an isosceles up to now. By dividing 180 minus 60 over 2, so the measures of angles here and here equals 60. So the triangle MXY, the shaded, is an equilateral triangle. Now the first lesson has ended, and we hope that I will complete the recordings of the following syllabus of the second term with you in next videos. Goodbye.